So the school might get something.
Okay, so it's just slowly pulling up. It's fantastic. Okay, right. So today we're doing usability patterns. So we talked about design patterns, and we talked about some of the programming patterns. Singletons and factories and flyweights and some of the spatial indexing patterns last week. This week we're going to talk about some of the usability patterns that you find in games, and specifically in games, which are common solutions to problems. Right? So as you guys developing particularly user interfaces in your games and that user experience, these are some of the patterns that you'll see. Right? So when we think of design patterns, we talk about, are they efficient, are they readable, and they're consistent, right? Because one of the advantages of using a pattern is that other people understand what you're doing. So they can look at something and go, oh yeah, that's the standard way of doing that, right? So when you get into a car, you don't have to work out which of these three levers is going to be the clutch, right? Because, you know, we've got a pattern for where they should be. And, you know, like you guys, if you drive, most of you will be using a floor-based H stick shifting. Yeah. So you've got a shifter in the car on this side for you guys. How many of you have driven in the UK where suddenly you get a bruised hand because every time you reach down for the gear stick, you're hitting the door because it's on the wrong side? Because I got that when I moved to Norway. But how many of you have driven a column shift car? Do you even know what a column shift car looks like?
Is it one of the ones that just go in one direction?
No, it's on the steering wheel column. There's a shifter that's an H shifter. No.
Oh, yeah.
Big knob that moves back and forward, up and down on the actual column of the, weird. And so when they first created cars, everybody was coming up with their own way of doing things, right? And so they're kind of all trying to compete about which is the best way of doing things. And eventually, standardization, it became better to do what everyone expects and to follow this standard pattern. It also becomes cheaper. So if you look at the car industry, what they did is they standardized on chassis. So they build one substructure and then just put different bodies on top of it to make it look different, because it's cheaper to have a factory that generates exactly the same chassis of the same size and the same shape and the same performance. You get that with computer hardware. This was a little controversial in the early O's, the late 90s, is that when they sold you different Intel Pentium machines, you could get a 4-core machine or a 2-core machine. The 2-core was actually a 4-core with 2 of them disabled, so they could sell it cheaper. But from a manufacturing point of view, they made 4-core. Everyone they made was 4-core because they made one production line that just did 4 cores. And then at the end, they took half of them, sold them as 2 cores because they could sell those cheap, and sold the rest as 4 cores. And they disabled it in software. Right? So and then, you know, there was a period where you could buy an upgrade for your machine to turn it from a 2-core into a 4-core machine, basically turning off the disabling of the extra cool cores you already had in your machine. So it's kind of and that felt strange, right? You've already made it, you've already built it, it's already there. Why are you letting me use it? Well, because then we would have to charge you more when you bought the machine. Right? So, and we've had the same argument with operating systems, right? So when Microsoft makes the home version of the operating system, they actually make the full pro version, and then they spend money to disable it so they can sell it cheaper. So it costs them more to then sell something cheaper. It seems an odd thing to do, to actively disable things. But this kind of making things, standardizing things is very useful. And so having it, rather than actually making 2 complete versions of Windows, right, that would be massively expensive. They standardize it so we make 1 version, and then we'll just do something to cosmetically make it look slightly different. And so you get the same for user interfaces, right? You standardize a lot of what happens. So, you know, your keyboard, your ASDW keyboard and mouse, you can do different things, but usually you still have a standardized way of interacting. Over time, like working out the column shift, if you've got lots of competing options, you get the design pattern event of different options competing, and eventually, usually a reasonable one, maybe not always the best one, but usually a reasonable solution gets standardized. So these are, like when we look at the design patterns, companies have tried other versions of these usually, and they've failed for various reasons. And so when you come up with the standardized pattern, it's usually reasonably efficient. It's usually reasonably understandable way of readable. And it's usually consistent with what everyone else is doing. Right? So those are some of the reasons to look at what are the patterns of solution, right? Rather than reinventing the wheel, what have other people done? With usability patterns, you're also looking at satisfaction, right? Because you want the user to be happy with the interaction. And one of the challenges, as we say in first year, good design is design you don't see, right? You don't notice when things work, right? And you shouldn't notice when they work. They should just work. And you don't really think about the sewage outlet from your house and where it is until it stops working, right? And backs up. Then you worry about like, where's it all going? Because when it just works and you never think about it. And so that's what we want from a lot of our interaction. So with HCI, human-computer interaction, interactive entertainment, this idea of being happy and satisfied and user interface design, when you're designing your interface for other people, we've got to remember there's that whole, you know, it's not the user's fault if they get it wrong, right? Because if they get it wrong, there's probably something we've done as well that has meant that that was hard to do. Now, sometimes in games, you intentionally make things difficult, right? So when designing usability patterns in games, some of them are intentionally difficult to master, right? Because we want to have you struggle. But as designers and developers, we should be making those choices. We should be actively choosing what is difficult to use rather than just having it haphazard because we couldn't be bothered. So, and we'll also look at some game-specific ones. Fun is going to be like fun is hard, right? Fun is like what's fun for you might be different for me. So how we see fun changes. Making an interface that's fun has some kind of non-scientific path to it. So I can't have a pattern that I know is going to work for fun. We can look at immersive environments and compelling experiences. So these are kind of some of the, when you start talking about game interfaces, these are some of the ones we really start looking at. So, challenge on user interface. So, the big red win button. This is probably the best interface for a university essay, where you could press a button and it would write your university essay for you with an A. And you just had like an A button, a B button, a C button, a D button, and you could press which one you wanted. Wouldn't that be a great interface for a word processor? It's written there. But one of the interesting phrases from learning is and one I kind of was listening to was in a podcast, the person who does the work does the learning. So it's the doing the work of writing the essay that should be helping you learn things, right? So if you do the work, you do the learning. If we do the work, we do the learning. Right? So I actually have to make you work to make you learn. As a gamer, the person who defeats the challenges is the one who's having fun, right? If you're not defeating any challenges, it's just easy. You just press a one button and say win. I go, well, oh, bang, I won the game. There's just, although that's the most efficient and like functionally productive interface, we don't do that in games because it will be the wrong pattern, right? So what we're looking at here is we're looking at how do we roll back from producing the best interface to producing something that's engaging. So one of the things we talk about is, so too much automation is bad, right? So when you're looking at your interface, you have to decide how many actions the player should be taking, what choices the player needs to be making that we choose not to automate for them, right? So one example is when I was working commercially here, we were doing a flash-based magazine for TV2. They had one of these. They also had like this, those terrible magazines where you can buy, plant shavers or things for making your hair stand on end, and just like weird like potato peelers where you could put it in a box and shake it and the potato peeler comes out, right? It's kind of all of those like weird gadgety things that you get in like glossy magazines. It was one of those, and they knew that the audience who read those liked bingo, right? So they wanted a digital version that had bingo on it, so that you'd have like cards on different pages. So you turn pages and you'd see a wee sticker. You click on it and it'd give you another bingo board. And then, you'd collect 5 of them and you could play bingo to win prizes, to get people to actually flick through the magazine and read stuff, right? So this was trying to do that. And the client, given it's on computer, can't you dot the numbers for them? So when the number comes up, can't you just dot it on the board? And it's, well, yes, we can, but then that is press button and watch a number come up and it fill up on the cards, and the number come up and it fill. You sit there and just watch it and do nothing, right? That auto bingo is not kind of the point of bingo. It's calling out a number and you got to kind of find them all and spot them all. It's the recognition is the game bit. And yes, we could automate it, but then there's no game anymore. You're just watching for a conclusion. And so we created 3 versions of bingo. I created 3 versions of bingo because, the clients are right. So we created auto bingo, hint bingo, and competitive bingo. So auto bingo was to say, look, you press go and it just automatically displays for you, and you just wait to see if you happen to win, okay? Which was fairly dull as a game experience. Hint bingo is I chose a number and then I show you all the locations where those numbers were for a couple of seconds, and then you had the whack-a-mole version, right? So you'd see where they were and you just whack them. And the other one was competition bingo, where I show you the number and you have to work out which numbers match, okay? And that came with the interface of, are you allowed to spot an incorrect number? Should you allow someone who's playing bingo to spot a number that didn't come up?
Yeah.
But yeah, so if you say yes, that's because you're interested in the gameplay of getting it right, right? And the error of thinking you have bingo, calling for bingo, and then it going, bah, you got it wrong, right? And you go, damn, right? So yes, I made a mistake, right? So that's all part of the game experience. But for him, he didn't understand games, so he was thinking, it's an activity other people enjoy, and so we just, obviously auto doing it, having the only being able to hit the ones that are valid. Do you guys ever had those hidden object games? Remember the hidden object games where you had like a complex scene and a hidden object? And you play the stupid ones in Flash, where you put your mouse over, and as soon as it changed the mouse pointer from a pointer to a hand, you go, oh, there's an object there, and I can click it. Right? Where the interface, because the way that it wanted to standardize is when something's clickable, it should give you a change the icon.
Or you could press tab and you get like a yellow search.
Tab, you got to go there. Tab, because your browser highlights selected option. So that's where the interface has changed your interaction with the intent of the game, right? And so standardizing things and using standard productivity tools, because browsers are productivity tools, right? They're supposed to be to make you faster at it. Putting a game interface on those, you may be able to break the intention of the game by the efficiency of the tool. So too much automation is bad, like automatically taking you to the next item actually breaks that game. However, you still want to be able to have clear actions. So hidden object games can get very annoying, right? Because particularly if you don't know what my next action is, right? And this is particularly hard for developers because you guys as developers, when you're making these games, you know what you're supposed to do, right? But when a player first comes to your game, they might get to a point and go, well, I don't know what to do now. There's no indication of where to go, right? So my kids playing Lego Jurassic World and the Lego games, they use transparent blue blocks to try and like guide you back onto the path of where you're supposed to go for the next thing to interact with. Because it's an open world, but there's still a hurdle to get to, right? There's still an indication of how to get somewhere. And so in games, having an indication of where the next sort of choke point, the next interaction is quite important, right? So having those clear actions, unless you truly are a complete sandbox game, then there are no choke points, there is no path to follow. But even then, you should have clear actions. I should know the kind of things that I'm able to do, right? There are, of course, with games, there are always genres that break or particular games that break these particular rules. So you can have games developed where there are secret actions, like the Tekken secret moves, where you had to work out a whole bunch of like joystick moves and keyboard presses, and suddenly you do an amazing special move, right? But that was about community building, and they actually kind of, those got shared, and so you were part of the community if you learned these moves, and people would try them out, right? But it was part of the game was to find out the actions. Usually that's frustrating, right? Usually that drives people away from the game. But you can try it, you can break rules. If you understand the rule, you can then try and break it. So knowing that clear actions is the normal way of doing it, and you're going to go, haha, I'm going to fool my players by having a special move which allows them something cool. Yep, you can do that, but be aware that you are breaking a kind of standard pattern of making clear instructions. I'm going to insult the Germans now, because we have one German. Yeah. So level of micromanagement. One of the things characterized by a bunch of German board games and computer games is that they tend to have a lot of small interactions, right? You tend to do a lot of micromanagement and interaction at quite fine detail, right? And it seems that culturally Germans are quite good at keeping many disparate kind of fine detail actions together, right? So they have these quite complex games. And so for some of them, they don't translate well to an American culture where they don't do micromanagement because that's too complex. And so they just want bigger controls. So you have to understand your audience for the level of management that your audience is interested in. And there's also an interesting thing with randomness. Do you guys know the difference between Euro games and American board games? Okay, so one guy knows the difference. What's the difference between Euro games and American games? Right?
It's mainly about the story and the player interaction, and not about the mechanics, and there's a little randomness inside.
So randomness. One of the interesting changes in the way you do randomness between American game and Euro game. Euro games will often have a phase of random thing happens, you choose response, right? Whereas American games have you do a response, and then you randomly roll a dice to see what influence that had, right? So do you get to make your choices before or after randomness has occurred? Because if you make your choices before randomness occurred, you don't really know the outcome of what you've made your decision on. So it feels more random because I'm going to attack. I'll roll a dice and see what the result was. Right? That's a different feel to I randomly allocate some situations and then I strategically work out my way through them. Right? So in the Euro games, you tend to have randomness and then player control, rather than player choice and then randomize the results of that. And so, and those are quite two quite different ways of managing interaction. Right? And those are two different patterns, right? So the Americans have a board game pattern style, which is choose events, see what randomly occurred, and the Euros have a style of randomly do some stuff to the world and then get the players to choose. Right? And that's to some extent with the micromanagement. If you know the situation, you can manage it. In the American style, something random is going to happen anyway, so there's no point in having fine control because it's going to be random, right? What actually happens. So these are different challenge levels and different types of challenge. Not right or wrong, but different patterns. And sometimes you get patterns that compete. So intuitive patterns, intuitiveness in the patterns, similar to other systems. So one of the things we get you to do is when you are looking at these games you're making, make sure you look at the other games like it and work out what your players will expect to do in those games, and then by default follow the same pattern. If you choose to do something different, it should be because you chose to make a difference and you wanted your game to stand out because of this thing, right? Otherwise, even if you don't necessarily particularly like the scheme, stick with what's standard for your type of game. Intuitiveness and naturalness of responses. As I was saying on Monday, this was the Wizard of Oz testing and the whole ask the player to do something, see what they do, and then work out how to control things. So for example, you're a wheelchair game, right? So we've got these guys doing VR and a wheelchair game. One of the things that they could potentially do is get people in, maybe even some of you, get them in, sit them down and say, right, move the wheelchair forward and just watch what they do with the controls. Right? Because if you're interested in what's a natural response, maybe because you've been developing the system, you've been thinking about it, you no longer have natural responses. Right? Because your brain has kind of already molded itself into how to interact. And so you need to get non kind of impregnated people who already have the idea to use your system and see what's natural. In game testing, we call these Kleenex testers because they're used once and throw away. Right? That's why they're Kleenex. They're the most expensive form of testing, right? Because you spend all the money to acquire them and then you only use them once. Right? Because once you've used them once, you can't see if it's their natural response anymore because they've already learned about the system. The only way to get cheap Kleenex testers, dementia sufferers. Because each time they use your system, it's new to them. However, that's quite a small restricted group and they might not be interested in the game. They may not be your target audience. So although you can work out what's natural for them, they're not necessarily the most natural group to use. We did make games for dementia sufferers, and it was very interesting to interview them about the game and them have no idea what you're talking about. Because 5 minutes after playing the game, they have no idea they just played a game. Right? It's, yes, very, very odd thing to have to work in that environment. But natural responses, if you can make your user interface feel natural, see what people naturally do, then you hopefully make it more hidden. Okay. As I said, testing what people do and then coding it. As you know, Monday, not many all of you here. One of the ways that I've seen people develop for the Wii was to get kids to do actions. Like, so there was they had a 2 Wiimote game, and they're looking at how do kids climb? How should you climb a ladder when you've got 2 Wiimotes? How should you duck? What's the action for ducking? What's the actions for running? What's the actions for climbing? when you give a kid 2 Wiimotes and tell them, right, run. Do they go up and down? Do they go in and out? Do they kind of go like this? Do they go like this? What are the natural actions? And when you jump, do you go down and up? Or do you just go up? Or do you just kind of jump forward? Like, and climbing, is it this? Or do you do both at the same time? What's natural flight? You don't know until you put it in their hands, right? So that's what they did. They put it in their hands, asked them to do stuff, and then coded whatever people did. I'd have asked us to do that to do with gesture controls, right? And that's quite interesting for VR. Any of you, because a couple of groups are interested in VR. If you're doing gesture controls, knowing what a gesture means, right? So we were looking at when you're doing manual, like doing play and pause and stop on a video. What's the gesture for stop? Some sort of. So if you've got your 2 like voice controllers, it's stop kind of, huh? And what would be the gesture for play? I'll press it to play and I'll press it to stop. What's pause? So I'm going to have something for stop. What's fast forward? Maybe rewind is that, and fast forward is that. But, you know, what's the natural? We don't know what those natural gestures are. You actually have to survey a bunch of people. There are some gestures for them, and people do come up with somewhat consistent gestures, but there'll always be outliers, right? And so getting gestures to be intuitive and natural is really hard, right? It's one of the things that they're still struggling with how to do gestures in AR and VR, is what are the natural gestures and what do people naturally do? And we find that they actually aren't very consistent. And that leads us to this idea of customization, right? If you're going to have people have different instincts on what they do, then maybe you need to customize their interfaces. So if you are using Windows, you can use something called GlovePi, which have I talked to you about GlovePi before? I don't think I have. GlovePi, he's a bit of an eco nut, but that's okay, because one of the things when you download his program, you have to tick a box saying you use 100% renewable energy in your company. And I'm not sure we do, but you know, I'll tick the box saying I think we do because hydro. But so that maps, he has a tool for mapping any system event to any other system event, right? Which allows you to customize your games so that anything, like you turn a Wiimote into the A key, you can turn the balance board into a joystick, you can map any system inputs to any system event, right? So it's very useful, and it's all scripted, right? So it does this automatically in the background. So that's a third-party customization. In your games, when we talk about function pointers and those mode control things, being able to customize your keys is something you guys have all become familiar with. I'm assuming that you've seen key customization systems. Yes, they're quite useful. Most people use the default configuration, but there are some of you who really need customization. Okay, so let's get down to some more specific patterns. So those are kind of general concepts. More specific pattern, the shield pattern. So the protective layer pattern, right? So when you do an action that is irreversible, before you complete the action, you pop up a thing saying, "Are you sure?" So that you can then click yes to say, actually, yes, I did mean to do that, right? You usually only have this on things which permanently change state and are significant, right? So so for example, if I want to delete a unit, right, and therefore throw away all its resources, that's usually an unusual thing to do, and so you probably want to warn on that, you know, this is going to cause you a loss of the unit and its resources. Right? Whereas in Minecraft, when you destroy a block, it's not going to get to the point where it goes, and the block's about to do it. Are you sure you want to destroy this block? Yes. Oh, are you sure? Yes. Are you? Right. That would be a terrible pattern to shield Minecraft destroying blocks, because you do it all the time, and you can put them back, and it's reversible. And creating a block, it doesn't put a shield pattern and saying, "Are you sure you wanted to build a block here?" Right? So you don't shield all the time, but you want to protect accidental actions. Now, there are some rules around this. So when you pop up a shield, like annoying confirmation, if you've clicked on something, when you pop up this box, you should never have yes directly over the thing you just clicked. Right? Because if I double click it, which means one was to select for destruction and the second click was to destroy it, that's not a useful pattern at all. I also get really annoyed when I'm doing something on my phone, right? And I'm doing something and a warning message will pop up just underneath where my finger is just pressing, and I pressed it and it disappears. And I go, what was that? What did I just do? So I did something. Couldn't see it for long enough. So knowing where the mouse pointer is when you create this window and putting it so they have to physically move to make a choice is part of the default pattern for a shield, right? So if you're going to do a shield, you have to know where the mouse pointer is, and you have to move the shield relative to that. You can't just put it in the top corner or put it in the bottom corner, assuming that they won't have clicked something in the bottom corner, right? Because there may be a unit in the bottom corner they've just clicked. So if you put a shield there, the button will be over top of it, right? You can break that pattern if you know that you want people to generally do exactly the same thing all the time and not think, and then you put the yes directly over top of the action, but then you're kind of intending them to not think about it, right? And that's not the standard shield pattern.
Yeah, but there was like with installers for Windows and software, when people started adding ads and third-party add-ons during installation, they did that on purpose, that you had to click next. But then just before the add one, there was a little delay on purpose, so that you thought it was just hanging, and then you clicked again, but then you confirmed that you wanted to add.
Confirmed, yeah. So that they screw with you to try and get you to click yes. So if you're going to do the shield pattern right, you move this. So there is a physical movement the person has to make with the mouse to get to either section. So if you make it click where the mouse point was there, so I have to choose physically down, right? So that's the standard in that pattern is to know where the game is. You generally do this thing, something like game exiting, right? So if I'm about to quit a game, usually you'll prop up a shield of, are you sure you want to quit the game? Right? Because if I accidentally bump Q and suddenly I'm back to desktop, and I go, oh God, now I have to go and take 10 minutes to get back in the game, right? That would be thoroughly annoying. So whenever somebody in your user testing does something and they kind of had response, you may have needed to have a shield on that action, right? Because anytime I accidentally do something and it annoys the user, then you put a shield over it to try and stop that happening. Unless it's something very common and like destroying a block and they go, oh no, I didn't mean to destroy that. And it's kind of, well, that's the game. You destroy blocks all the time. So you have to understand the kind of the environment you're in. So unable to undo the action when you're changing action types, and often the pattern has the ability, and you've seen this as never ask me again checkbox. The challenge with that is I'm often like, so with my phone, when it says, do you want to open this in this application always? I go, well, no, sometimes I want to choose which application. Most of the time I want it in the browser. Sometimes I want it in the PDF viewer, right? But now I have to make the choice all the time because otherwise I have to go in my settings and it'll be a hassle to go and find the particular app, right? So that app choice thing, I would like a different interface for that one than just bury this in an interface somewhere, right? It needs to kind of, if I long press, it'll give me a choice. If I just tap, it'll go to the normal one, right? So I need a different interface for that because the removing all confirmations is not quite what I want, but I just want to remove most of them. State information is another standard pattern in games. And so state information, this is from Diablo. I don't know if any of you played the original Diablo. So you're just still, you're old enough to have played Diablo?
Yeah, I mean, I was kind of young.
So, you know, the massacring of hell-spawn creatures was something your parents didn't mind you doing.
Yeah, no, actually, I played it on someone else's computer.
Ah, yeah, no. So one of like the first PC that I bought, right? Because I'd had the first PC I bought when I moved in with my first wife. It had it didn't have a CD drive, so I bought a secondhand CD drive, and when I put the CD drive in and plugged it in, it opened and there was a disc in it, and it was a pirated Diablo disc. So I had Diablo as a free add-in for my CD drive. So I oh sweet, okay, I'll play Diablo for a while. So so I got to play Diablo for it, and these constantly watching your health and your mana change. Though that state information, that information about just like the pieces on the chessboard, knowing which state you're in, right? Without these two indicators, not knowing how close to death you are, or not knowing how much reserve of power you had, making decisions much harder, right? It would be completely different and much more confusing game. But there are a lot of kind of, as your health gets lower, your stress gets higher. There's lots of kind of engagement that happens by knowing state. So in VR games, how do you show state? This is actively a discussion in the VR community, right? Because they've had the whole, do we have a HUD display that moves with your head that is locked in place, right? And so is hovering. So some games have put you in spacesuits and helmets, and inside the helmet you're in, you've got your HUD information, right? So you got status information in your helmet, and so you can look around, but the HUD information is in the helmet. So you can move, and you do big moves, right? You move the whole suit around, but when you look around, you're in, this helmet thing, right? So, and they do that for cars, so you have your status information in the car dashboard. You can look around, but you create a machinery around you that has status information. So you guys on your wheelchair, you could have status information like on the wheelchair somewhere, right? Because that would be a fixed object in relation to the vehicle. They've tried having, Out of Ammo does an interesting one where it uses a smartwatch as your status information. So you've got your controllers. When you rotate your controller and look kind of at the back, you've got a watch, and this has status information. And then you can actually click on it with the other hand and change its information, scroll through information, and you see some will pop up a tablet basically on your hand, right? And so when you want to go menu, you rotate it over here and it pops up the tablet, so you can view information and potentially do stuff with the HUD, and then roll it back and game, right? So it's a you have to look at it version. In some first-person shooter games, when you've got third-person perspective, when you want to have no HUD, they'll put the information on the back of the character you're looking at because you're third person, so they can put health information embedded in the game. In Doom, the variation, you had a picture of your head, and it slowly got more bloodied as you lost health, right? So they tried to have an abstracty one. This was just like a bar chart, right? So this is just a bar that lowered and raised. Some, like one of the hard ones is if, like when you've got a pointer and you move around and select things, you get information about them. And so where to put that information? Do you put it on your hand? Do you put it, like, because you know how far away the object is, do you put it on the object? But then if it's too small, do you make it bigger? Do you put it at some known distance between you and the object where you pop up information sheet? Yeah, we still don't know, right? That's up to, we're still experimenting with how to do this well in VR, right? And there are some challenges to do with eyesight changes, and so yeah, we're in a flux state. And a lot of 2D games where we have got to the point where we know how to do this, right? And pretty standard, and we just do them. VR, we're still thinking about it. Having a state indicator on the enemy AIs, a lot of students deal with this in their games is like, do you show the health of an enemy? Yes or no?
Depends.
Depends. I think it probably depends, right? Some games, it's incredibly frustrating not to know how close to death your enemy is, right? But if you've got 100 enemies, you don't want to have like all their green health bars overlaying on top of each other because that's really, really annoying. And so some games will only show you ones that have been damaged, right? So if a unit's been damaged, it will show you that it's below maximum health. If it's full health, it won't show you anything. So that's how you know it's full health. And some combination, you can try and make an animation of the creature that shows that it's changing, like limbs falling off or more bloodied or changing color or starting to flash or various ways of telling you that the health is changing. One of the kind of state information things that was quite interesting is from the Halo games when Chris was working on the AI for the mini units, right? So you had so in the original Halo game you had like the big beast units, and then you had a bunch of like triangular shaped little guys who were following him around, right? And they had an AI mechanic where when you shot one of the beasts, all the little guys that were around would run away, right? And when they play tested it, none of the players noticed at all this mechanic. Right? They'd just be shooting stuff, and the big guy would die, and the other one would be running away, but then they'd turn and shoot something else. Right? So they never saw this interesting AI mechanic they'd put in. Because what they wanted people to be able to use is use that to shoot the beast, see the other, and then because he'd fallen, the other was running away, they weren't shooting at you, you could now like run up and take cover closer and then shoot it. Right? So it was supposed to be a mechanic, but nobody knew about it. So they did the how do you tell the player about that state change in the AI's behavior. All right? Now, in some games, you'll hear audio track from your enemies talking about things like, we're going to flank him, he's over there, I spotted him. Right? You've heard some, like they'll have audio track from your enemies. In some of the games, like the flanking ones, where I know for some of those where it's, oh, let's flank him. There is no mechanic in the AI for flanking. They just tell you that. And then if you happen to spot somebody who looks like they're flanking, you as a player will think that it's clever and will think that it flanked you. And that's all they need you to do is think that the AI is clever. It doesn't have to actually be clever. So sometimes all those are just lies to make you think the AI is cleverer than it is. And so that's giving you false state information. The other way, and what they did in Halo, is that to get the player to understand the state of the AI, they basically had to do ham acting of it, right? So what the little creatures do, instead of just turning away and running away, they go, and do like stupid overacting of being afraid. But that was because none of the players, and once they did that, the players spotted it and then used that mechanic in the game and felt awesome because, you know, haha, I've made you afraid of me, right? But without overacting the fear, people didn't know the state of the system, right? So this is about informing the player of that. So often you don't want to be subtle about the state of your AI or the state of the game. You might know as a developer exactly what state everything's in, right? Because you make the game. But your player doesn't, and so you have to be very explicit with them about the state of the game you're in. Okay? And you know, in StarCraft 2, the very early building cycles were all about, you know, showing you the state changing, right? Because you know, it could have been just nothing, and then a minute later, built. Wouldn't change the mechanics in any way, but the animation of the state is changing makes you feel more engaged as a player. Another standard design pattern in games, automatic mode cancellation. So this one you might not have noticed so much because it's usually designed just to work. So the idea is when you've clicked deep into a hierarchy and you click out somewhere, that it should cancel away all of what you're doing and let you keep interacting. So you shouldn't have to manually step back out of the deep interaction to get to a safe state and then continue. Right? So you guys will have noticed this, and when you click, and you've been doing some selecting, you click to the side or you press escape. And if you press escape, it takes you back out of whatever you're doing, back to the normal state of the game. Right? That's a mode cancellation. Now, automatic mode cancellation is you don't have to press escape. You just click somewhere which isn't involved in what you're doing, and it goes, oh, you clicked away, I'll just automatically cancel all of that. Right? Rather than sitting there trying to click and think, oh, how do I, oh, that's right, I have to press escape. Right? Because also, pressing escape, it does take you in that sort of human unit. You start seeing the interface. Right? So when you select another gallery element, cancels the mode. It is one that's hard to pick up on because it's one that just works, and you guys probably don't notice it. So try and notice this particular pattern. And in your own game, the reason why you, as a developer, you sometimes struggle to see this is because you know how to get out of the situation. And you generally don't go into a situation you're not intending to be in because you know what you're doing. And so you never get into a state where you had to suddenly get out of whatever I was doing and go back to the game because I'm testing this thing. So I'm going to test it and I'll step back out and I'll test this thing, I'll step back out. So because I'm fully aware and I know how the game works, I never get myself into a state where I need automatic mode cancellation, so you don't test it properly. But your players will almost always get into situations where they're not sure what they're supposed to be doing now and want to get out of that situation. So select your unit, moving units, and if you click on a unit, if you're going to unit destination, if you click on another unit, is it a mode cancellation? Is it part of the mode? How do I know what's going to happen when I click on another unit? There's a lot of is there a right-click option menu? If I've said move and I've decided I want to cancel that move, what do I do to get out of it? Is it just a right-click and it will get me all out of everything? What's the mode cancellation mode for that? Right? Because if I click somewhere, my unit's going to start moving there. So I want to not move. So I've got to have some exit strategy. And also, if you click on a unit, would you then move to that unit? When that unit moves, do you follow it? What does that mean? Have I cancelled out of mode, or have I selected a new unit? Or you've got to understand what your interactions are happening, and you've got to test it with your players to see. Magnetism. Now, this one is sort of in that kind of slightly controversial. So in the VR ball game, in the AR ball game I have, one of the things I made an assumption of when they play the bomb game is that they're trying to get the ball across the net, right? So if you're making a ping pong game in the Wii, right, and you have the Wiimote and you have the ball coming towards you, when someone swings the Wiimote, you assume they're trying to hit the ball back over the net. Right? And so if they've missed by just a little bit, do you completely punish them and say, no, you missed? Or do you say, well, okay, yeah, no, you got your timing about right, so I'm going to let you hit the ball? I found this when I tried, so I've been playing Wii table tennis, and then I got the Move, PlayStation Move, and I tried the tennis and the PlayStation Move, and I would try and swipe too early, and I'd swing, and I'd just miss because the ball just missed my racket. And it's kind of, that's really annoying. So how much should you help the player to be better at the game than they actually are, given that you know what the player is trying to achieve? So this particular magnetism video, hopefully it's still loaded. So this was in Halo, and so Halo on PC had aim assist, right? So I can maximize the screen to make it easier to see. So so these are the original weapons on the PC game. So this guy shoots the bullet, right? And see, well, if you're shooting at someone, you're probably trying to shoot them. Now, those bullets aren't landing in the center here. Here, they land in the center. But when I go close to him, they get magnetized in towards him. So you can see the circles there rather than here. And so what Halo did is even though I'm now, yes, not actually aiming at him, right? If I am far enough away, it will shoot right in the center. But when I get close, I'm completely missing him, right? But now I'm going to hit him because my bullet gets magnetized in because it knows that the player's trying to shoot the bad guy. And so what they're trying to do is work out, so yes, the shield's popped even though he's completely missing. Because one of the choices they had on console was, do you do, yeah, how much aim assist do you do? So one of the problems with the joysticks, right? If you've got two dual joysticks, I think we can probably, yeah. You get the idea. One of the problems with two joysticks, there's a couple of aiming modes. One aiming mode is you have auto aiming. So I aim at the nearest enemy, and then I flick left with the joystick, and it flicks to the next enemy. And I flick left, and it flicks to the next enemy left. And I flick right, flicks to the next enemy right. Right. So that's a auto tracking, select your enemy to shoot at mode. Right. But players don't feel good about that because it feels like it's cheating. Right? So so instead of having it auto aim for you, they had this magnetism, which is kind of auto aiming, right? So as long as you're close, the bullets magnetize in and actually hit the thing that you're kind of pointing at. And so what they did is they did a lot of user testing to work out how much magnetism before players noticed it. Right? So here, these people are standing statically, right? Which is why you've got time to have your enemy stand there and shoot just near them. However, if that's running around AI that isn't standing still, you're going to be tracking, so you're never going to know whether you were just off or not. So it kind of creates a wider hitbox, but it did it by actually serving the object because it does object collisions with your body. So what it does, instead of making your body bigger, which means you would have collided with objects as well, with a big wider body, because then your collision box was bigger, it moved objects, magnetized them into you. And you can do the same thing with interactions. Sometimes you can do this with the mouse. When someone's over something useful, you hold the mouse there and then let it come out. So you don't have a smooth mouse moving over. It actually magnetizes it to the object you might want to click on, and then it flicks out. So it actually lingers over things that are relevant. Right? So there are magnetism ways of doing this. So things like pixel perfect selection. I don't know if you guys have ever had the web experience of a selectable image that when you mouse over it changes to another image. And when that image doesn't have a pixel at the point your mouse is, and so it flicks back to the unselected image, and then goes, oh, you've selected me. And it goes select image, and then unselect it, and just flicks there, sits flicking as it goes on and off and on and off and on and off, because the collision box suddenly, like every time it switches to the you're mousing over me icon, it's no longer being moused over. Right? You can set that up. It's really annoying. Most people do that and they go, oh, right, okay, no, we'll just do a standard collision box around the whole thing. Right? So you don't get this in out. But if you're doing pixel perfect collisions, you know, you miss a pixel when your selected mode is different pixel shape to your normal mode. Suddenly you've got this mode fighting. So having boundary spheres and objects, spheres are mathematically faster to calculate. Bounding boxes are often easier to understand. So you've got to work out which one is going to be faster. Bounding boxes can be reasonably quick, but have more if statements, and so don't work as well for branching pipelines. So although the math looks simpler, it's actually harder for the CPU to do. Right? So this is an optimization you've got to try on your own machine. And you can also adjust the amount of magnetism, the amount of kind of attraction to an object, according to the kind of mode you're in, right? So possibly, right? So when I'm trying to select a unit, making the hitbox bigger, right? So it's easier to click, right? So if I know I'm going to try and shoot, so I seek bombard a building, I will select whatever building is closest to the mouse when you click, unless you're really far away from any building, and then I'll just say, I'll cancel and go, nah, you can't shoot there. All right, so the size of this magnetism drawing you in to where you want it to be varies. So for Halo 1, that's how they dealt with making people feel better on the controllers than they actually were. And that's why people prefer that. And so one of the things that they feel is why people preferred Halo to other shooter games on console is because Halo, you hit more often. Because it was cheating, right? It was making you better at the game because it knew what you were trying to do. Right? So that's the sort of thing. That's another kind of magnetism. Now we've got a couple more slides, and then I'll give you, and then we can talk about the projects and give you a break. So focus. I had probably one of the more annoying focus patterns that I had was where you would have seen this. You grey out options you don't have, right? You're used to this idea that you grey out options that aren't valid. You've seen that in menus, yeah. It's useful to grey out options so that you can get the user's attention on the valid options. It's better to grey them than to make them disappear, right? Because if you have a list of 6 things you can do, and you grey out 3 of them, and you've got 3 available, then I can click on those 3. If I only see 3 available, I don't know that there might be other options if I've selected a different unit, or if I'm in a different mode, or I've got a higher level, or whatever it is that unlocks those other grayed out options. If I can't see them, if they've just shortened the list, then I don't know they exist, and so I can't go looking for them. Also, humans are very pattern specific, right? And so if we're used to hitting the 3rd option on the list, if you add a new option at the top and shunt everything down 1, I'll still hit the 3rd option on the list without looking. And if that's changed, that's gonna annoy me, right? Really bad, right? So it's far better to have grayed out that option than it is to insert it later, right? So basically never insert things into a list unless, well, basically don't do that, right? People learn list positions. And yeah, as I said, humans are very pattern focused. One of the ones that I had very annoying when I was using Microsoft Word, like Microsoft PowerPoint, and I hate it when it takes over my screen and forces me to have a second screen to have the presentation and have lecture slide notes on my own machine. But you plug in, you do your presentation, right? So you set it up, and there's an option in the menu for present on second screen, right? And it's a checkbox. That was in the old version. And so I checked it because I said, okay, yeah, I'll check that box and I'll present on second screen. I went back to my office and I opened up PowerPoint and I went present, and it presented on the second screen, which wasn't plugged in because I didn't have a screen with me. So I went, oh, okay, I'll just go to the menu and uncheck that. So I went to the menu and it's grayed, but checked. Couldn't click on it to tell it to stop presenting on the non-existent second monitor. So I had to go into my friend's office, get his screen, plug his screen into my laptop, so I could then select the option to turn off the second screen, then unplug the screen and go back to my office, right? And that was kind of graying out of mode without fixing the mode to actually something that was sensible when grayed out, right? It'd be fine to gray it out if it then also switched me into the unchecked mode so I couldn't turn it on, right? But it kind of mismatched those two. You do have a little bit of challenge with achievements in this, right? So showing achievements. Because if you have achievements in your game, there'll be some of your players who are focused on getting all the achievements in your game. If you show them with the grayed out, these are the future achievements you could have, right? That's kind of a teaser, as in, hey, this would be something you could do in the future. This is great, right? You've got to watch with the teasing and taunting mode where, and you get this for some games. If you have complete first try without dying, and someone dies, and then you show the achievements, and you show that one's now been crossed out, even before they knew it was an option to try and achieve for, right? Because it's the first try, and so you haven't shown them the achievements yet, and they die, and then you show them, ha, you can't get that one anymore, right? That's just mean, right? It's I'm showing you an achievement you can never now achieve, and for some of your players, that will just stupid game. I'm never going to play you because now I can't collect them all. So seeing what next could be enticing shows players what they can never have. So for example, if you have tech branches, right, potentially, and you've selected some tech, which invalidates a whole bunch of things, showing them all the things they can't now have is kind of a bit of ha, you can never have this. Kind of, don't need to see what I can no longer have, right? If they could go back and start with a different character, you may be then saying, hey, this is what this other character could do, right? But that would be for people who want to see that other character, not necessarily every time you look at your tech tree, you see all the things you can never have. And the last one, you guys have all done Fitts law? Did you do Fitts law in any of you usability stuff? Okay, so there are very few, so in usability, there aren't that many kind of mathematical proofs of things, right? Because a lot of usability is subjective, and a lot of usability is about humans trying things. Fitts law is one of the few mathematical formulas you can put in when you're talking about usability and go, haha, it's a proved formula, great. So the formula is time is some constant by a constant times the log 2 of 1 plus distance over width, right? Or size, W, right? And so this is for how long it takes you to click a button based on how far away it is and how big it is. Right? So a small button a long way away, you have to move to it and then slow down and physically slow down until you can click the small button. If it's a big button, you can start your motion, and so long as you're passing through it, you can click on it. And so one of the things to do is with edge buttons, so with the edge of the screen, because the width becomes infinite, you just have to throw your mouse at that direction and click. You can get the sidebar, right? So the edges of the screen get like a special measure in here because this becomes very long and it becomes more of these two constants, right? Because you divide this by infinity, which means you get the distance doesn't matter anymore because you're just going to flick your hand over there, and so you get log 2, like this constant times log 2 of 1 plus the other constant, right? So this is a formula that we use to work out mouse interactions, joystick interactions, because mouse is different to joysticks. It's just joysticks has a maximum velocity, and that goes in here because this is related to the distance you're having to travel. So if you have a maximum velocity, you're going to limit how fast you can travel, right? So the idea is that if you have large buttons, then it's faster to click them, even if you're at a distance. Or you can have smaller buttons so long as the buttons are quite close to each other, and then they're also quite fast. The challenge with, and so that's why with Windows 8, I don't know if any of you are still running Windows 8, or have you moved to Windows 10? How many of you are Windows 7? Windows ME? Good. XP? Excellent. How many Windows 8 are there? Are there any Windows 8? Are you all Windows 10 or Linux? 10. Excellent. Do you remember Windows 8? Thank you. Yes. But it had contextual menus that when you went to the side of the screen, it popped up a menu. Do you remember, like, when you hit yeah. With mobile screens, and that's what using Fitts law, basically saying, oh, that'll be easy because you can throw your mouse at the corner of the screen and then I can pop up a menu. So it's a fast way of getting the menu. So it was using this law. The problem is when you had two screens, the edge of the screen, the mouse would go to it and then go through to the next screen. And so you'd never be able to get to the edge of the screen because you'd always go through it. And so you'd have to go through and then back and like wiggle to try and work out where the edge of your screen was. Did any of you do that? Some of you did. Some of you didn't. They didn't have two screen things. But they actually did. Their earlier pattern, the magnetism pattern, they actually had that on there. So your mouse would go up to it and pause on the edge of the screen before it would flick through, just to try to help you click there. But yeah, it never really worked. Right? It just didn't, yeah. And that was a feature you could turn on and off, and yeah, it was a bad thing. So the idea with Pitt's law, as I said, is when you move your hand, you have a high velocity stage, and then you have a final movement phase where you decelerate, right? So one of the things interesting, if you look at human movement, when I first go to grab something, I actually initiate a big movement in the general direction of my target, right? My first initial movement isn't perfectly aligned with the thing I'm trying to grab, right? So I don't go bang, and if I just continue that movement, I'd actually hit the thing. I might miss it just slightly either way, but I start my movement quickly in the general direction. As I get close, I then do the fine adjustment to actually slow down and grab it. All right, so I don't pre-plan everything. I just say, oh, it's that direction, and then slow down when I get there. So you have a high velocity stage where you initiate movement, and then a slowdown where you start doing the fine movements. That's what we do with our mouse. That's how we move with the hand controllers. And so understanding your initial movement versus your final movement, and that the difference allows you to build interfaces that work better for humans, because you know that their first move is going to be big and fast, and their slow movements are going to be near the end. Right, so those were some usability patterns. It's 23 past. Do you have questions? No? So I think for your wheelchair, you should get people, so if you come up and test on Friday with some randoms, one of the things you do is put them in and say, how would you move the chair? Or steer the chair forward, and then just, record, record position of the hand, but also just watch what they do and note it down. Right? Because hopefully they'll do this. But I don't know, maybe they'll do down here, or maybe they'll grab it here, or maybe they'll grab the hubs of the wheels, or see what they do, right? That was rather than decide beforehand, you might use that as a user test. For some of the others of you who are making platformer games, have a lot of standard usability patterns. I've never liked platformer games where I have to do leaps of faith, where I get to a point and I have no idea whether or not there is a ledge down there, and I just have to leap and hope, and then fall to my death, and then go, well, is there and I'm going so fast I can't tell if what ledges are there, and then do I jump a little bit, or do I try and jump further, or that's really annoying. Right? So mini-maps can be quite useful as a design pack for that, right? And if you're using most games will give you a way of doing a mini-map, and even if you can't, create a secondary screen that is a render of your game, add a small, and put it up there. So with a camera that's further back, so you get a mini version of your game. So those sort of things. So you're not doing kind of random leaps of faith. Almost always when you guys make platform games, you always make them too hard. Every platforming game I've played with you has always been too hard. Right? Because you guys are good platforming game players. Particularly if you've chosen to make a platforming game, it's probably because you enjoy platforming games, which means you're highly skilled at platforming games. And so for you breathe through it and say, well, it's so easy. And I get to the first jump and go, boom. And I go, boom. No, okay, D. Can't get any further in this game. You're going to fail. So, don't make me angry at your game. So make it ridiculously easy on the first levels would be beneficial. Also, make playthrough videos. Right? So that can also help your users when they go online to see how to do something. Is you as developers make playthroughs and make kind of game tutorials. Those also used for us as lecturers. If you submit your gameplay as a speed up YouTube video or something of your gameplay, that helps us get through your game faster and also make sure we've seen everything you wanted to see, right? Because if you just give us a game and tell us to play through it, we might not see everything you want us to see. Right? So you should guys be used to at least screen capturing, and if you can, streaming of your gameplay. Right, so if you're not done any streaming before, you should probably think about how do I do screen capture. Okay, any other questions? Nothing from you guys? You're all working on your projects. You know what you're doing. You seem to be making progress. So we'll have an update on Monday afternoon. Great, cool. Okay, go away. Have a good Wednesday.
thingy to the other thingy.